and welcome back to Precalculus 1, section 7.3. We are talking about partial fraction decomposition. So it contains fractions, which I know you're all delighted to hear. And it is the backwards procedure from addition of rational expressions from your algebra class. So I will just give you an example from algebra, and then we will reverse it, which is what we are learning. So let's say you have 3 over x plus 2 plus, say, 5 over x minus 3. It doesn't really matter what the numbers are. So this is a problem from algebra where you are supposed to add these two fractions, these two rational expressions. And the way you did this was you would find the least common denominator, LCD. In this case, it's x plus 2, x minus 3. And then you would multiply both of these fractions with whatever is missing in denominator so that you can add them. So in this case, x minus 3 on the left and x plus 2 on the right. And what you get is the common denominator x plus 2, x minus 3. That's a 3. And then we have 3x minus 9 plus 5x plus 10. And together, they are 8x plus 1. And then we have x plus 2 and x minus 3. This is the algebra stuff, yes. But what we want to do is we are going backwards. So we are starting here, and we want to get these two. So we are decomposing this big fraction, and we are decomposing it over the factors of the denominator. In order for us to be able to do this, we have to memorize 4 different cases for setup, and then use those cases when we have to. That depends on factors. So I will first demonstrate this procedure, then I will list cases, and then if we have time, I'll do one more example, and then next class I'll do maybe 2 other examples. This is on your last lab, right? And it could be on the final, so pay attention. So here is the procedure. I'm just going to write this way, algebra, and this way, partial fraction decomposition. So what am I trying to do? I am trying to take 8x plus 1 divided by x squared minus x minus 6. So the problem will look like this. This is how the problem looks like when you are supposed to decompose it. Your first step is to factor denominator, which will be 8x plus 1 divided by x plus 2, x minus 3. So the problem is given as x squared minus x minus 6, and you factor that. So this is where the problem begins. All right, that's where it begins. And this is your first step, factor denominator. Now, the part that you will be memorizing, which is what I'm going to write after this example, is that when you have linear factors, like x plus 2, x minus 3, x plus 8, whatever it is, then the setup for partial fraction decomposition looks like this. A over x plus 2 plus b over x minus 3. So that's the setup part. And that comes from the piece that you memorize. The rest of the procedure is, well, now you have to add these in terms of a's and b's. So now you have to add those. So what we are going to do, we are going to say x minus 3, x plus 2. We are looking for a and b, and then we're done, right? So we're going to have ax minus 3a plus bx plus 2b divided by x minus 3, x plus 2. Guys, this is equal to 8x plus 1 divided by x minus 3x plus 2. These two are equal. So they have the same denominators. That means that numerators are the same. So ax, and I'll just put bx next, and then minus 3a plus 2b. I rearranged x's first. 8x plus 1. The denominators cancel on both sides if you multiply both sides by the denominator. And now, this is the part where you get stuck. So if you understand this, you're technically done. This part here has x, and this part here has no x, has a constant. So now, if I factor this x, I will get a plus b times x minus 3a plus 2b, and then it's equal to 8x plus 1. These two expressions are equal where coefficients of x are equal and when numbers are equal. So that gives me two equations. A plus b is 8, and the blue equation minus 3a plus 2b is 1. And you have two equations, two unknowns, which you can solve any way you want. Maybe times 3, let's say, top equation, and then you times 3 on the top. So you have 3a plus 3b is 24. And then minus 3a plus 2b is 1. When you add the two equations, 3a will cancel. You get 5b is 25, and there's your b is 5. As soon as you have b is 5, a must be 3, because they have to add to 8. Multiply the entire equation by 3, right? So now all I need to do is to go back and see a over x. So 3 over x plus 2, I think. And then 5 over x minus 3.
Why is A, B?
And let me just check, is this correct?
How did you get the
Yes, it was. See?
How did you get the A equals 3?
From this equation here, a and b have to add to 8. If b is 5, b must be 3.
Wait, so it's always going to be the ax minus 3a plus bx plus 2b like that? It's always going to be like that?
Hell no.
No, it's going to be exactly the same.
Imagine how many numbers are there in the world, and then combinations of those.
So it's only...
You only have that equation
2 because
of the denominators, yes, but denominators can have any numbers, and that will change all the coefficients in all the equations. And then it also depends on top of that how many factors you have. You can have 3 factors, you can have repeated factors. You can have 2 by 2, 3 by 3, 4 by 4 systems. You can have complete mess of these things. And you know what the interesting part about this is to realize? This is just a step that you do for the calculus 2 problem. Yeah, I'm getting there. I know, Calc 2 is awesome. Here. This is the that class. So here. Well, that's what I'll be writing soon.
I like how you just wrote blah.
That's exactly what's going to happen in 5 minutes. Look, guys, you are supposed to integrate this term, right? But it can't be done in any other way than partial fraction decomposition. So, look, exactly the steps we did without the calculus around it. We just did the guts of the problem. And then we did this sphere. You recognize all of this. You recognize me underlining red and blue, identical to what I did in your class. Here is the system, solving it. Here's my A and B. And then those A and B go where A and B are supposed to go. And then I proceed with calculus after that. Right? So this is now calculus, how integrate. There is actually more steps there which we skipped because we know some stuff, but there is about half a page work there. So this procedure, those of you going to Calc 2, and there is more of this. This is in Calc 2 partial fraction decomposition, but you have it again when we do the telescoping series, which is right here. So infinite series. Except at that point, when you are so far in the Calc 2 semester, what you write in half a page, you kind of write in 3 lines, because by that time you're very proficient with this. This is just something you deal with quickly. This is possible to learn if you practice enough to be very quick and very proficient with these things. The next course, differential equations, inverse Laplace transform, use the same thing. So it will be used over and over again. Those of you going on with mathematics for engineering and so on, guys, you have to know this, because a lot of different methods depend on it. What do you have to memorize? Well, here we go. When you factor this, what happens is you will get a certain amount of factors in denominator. How many and what they are depends on which type of polynomial you had over here. This was a basic trinomial, so pretty much no-brainer. You got this in 1 second. But there could be different types, and you can have more than 2 factors over here. So yes, you will. So you'll have to worry about complete factoring, which is what we did in chapter 5. You're not going to have to do all of the rational roots and zeros and divisions and stuff, but that can be incorporated in a very interesting overall kind of problem that covers multiple sections. Most likely will not. So this part is what governs, this denominator here is what governs how this part gets set up. There are 4 different setups which you have to memorize, and that's where that block came in that you saw briefly. Because it doesn't matter what this is, it only matters what is on in the denominator of this fraction. So, what are the things that you have to memorize? You are memorizing that when you have blah over x minus c, so when the denominator is linear, the setup is a over that x minus c. Guys, this includes single x as well. So if you just have x, because it's considered like x plus 0, c is 0. So if you have just x, or you have x plus 2, or x minus 10, then it is a over x minus, or x plus 2, x minus 2, x minus 10, whatever it is. Then you can have repeated. Then you can have repeated linear, which sets up as this. Then you can have unfactorable quadratic. Like, let's say x squared plus 100. That factors over complex numbers. So unfactorable quadratic, you can factor it into linears. In that case, the setup is this. And then you have one more, which is a repeated unfactorable quadratic. Which sets up similar. So these are the 4 setups. Now, they're very systematic, if you ask me, in terms of memorizing, because this is x to the first power, this is x to the 0th power, there's no x. This is x squared, this is a single x. So you go from a quadratic into a linear, or from linear into a constant. So from that point, if you kind of see that, that's the first thing you're remembering. Now look, each repeated one looks the same as the original with addition of the repeated term. And the same goes for this one. So they're all comparable, right? I don't think it's difficult to remember at all. But if you think it's difficult, then just write it 50 times, you'll have no issues. So these are the setups. Calculations come later. So we'll do first, let's do a setup problem. We'll not be solving this one. I just want to practice setup. So let's say you have x minus 3, x squared plus 100. You can pile them up as many as you want and whatever type. So this is how I do this. X is a linear, so a over x. Plus x minus 3 is a linear. Well, a is taken already, so b over x minus 3. X squared plus 100. I cannot factor that, which means cx plus d over x squared plus 100. So this is the setup. And the setup corresponds to the list that you had from those. Every time you see a linear, it's going to be a number over that denominator. Every time you see a quadratic, which you cannot factor any further, it has to be ax plus b or cx plus d or whatever letters are next ones that are available. So we used up a. I understand that each setup for this one looks like it's a over, right? But it's not. It's not. Each setup is not a. There's some lag over here, so it's. So I understand that this is a letter A, but that letter could be B, C, D, could be any letter. You take the first available letter. So I did go A all the time. But as you can see, as I did the setup, this is linear, so they just have the constants. Since I took A for the first one, I can't use it again for the second. So as you're taking the letters, you go with the next one every time. So that was the practicing setup a little bit. And we'll do one example and then walk away, right? For this. We'll do more next class. We'll do the review. Exam is on Thursday. Another review on Tuesday. Final exam on Thursday. And we're done. So, guys, in 2 weeks at this time, you'll be already done with this course. You will submit the lab 4 and the project, and the final will be over because I think it's earlier, right? So, no, I think the time is 12:30. Yeah. So. 12:30 to 2:30, so by this time you'll be already in Greece.
Yeah. Well, it's spring break.
You see how much education is devalued when you actually can travel during the spring break? It's terrible. Spring break used to be the time for students to actually catch up on all the study and all the work. Yeah? And now you're planning a trip. This is, I know, this is how, and I'm live on stream, I know that. This is how pathetic education is today.
Yeah, we're going to Greece to study. Did you not get that? I said it was going to be lit. That's what I meant.
Exactly.
My like protractor and things up here.
Pyramids are in Egypt.
Guys, I'm going to do one example which is important for your next lab. Otherwise, you'll be crying. So, they already gave us the factor denominator, which means that I can go immediately into setting it up. Please, shh, guys, he's going to tell us the, Ryan, let's go.
We got the x minus 1 squared.
Okay.
The a over x minus c plus b over x minus c squared.
Nice.
And then it's just plus a over x.
I'm sorry.
I'll switch these actually to match. All right. So this is the setup. This is the correct setup for this problem.
Wow.
We have a repeated linear. So here it is, repeated linear. Since it's a linear, you get the constant on top. And then you have a linear, which is just a constant on top. Now, we multiply this. You have the common denominator on the left. You see what the common denominator is. So you multiply by whatever is missing into each one of these. So in the first one, you are missing one of the x minus 1s and x plus 1. In the middle one, you are missing x plus 1. And in the last one, you are missing both of the x minus 1s. Because the common denominator is 2 x minus 1s, right? Because it's squared, and x plus 1. So whatever is missing, you have to multiply that. And then you FOIL. So you have a x minus 1, x plus 1, plus b times x plus 1, plus c times x minus 1 squared to be equal to x squared, which is this x squared. So maybe I should put like a star or something so you know where it comes from. Now, FOIL everything. This stuff over here is x squared minus 1. So ax squared minus a plus bx plus b and plus cx squared minus 2cx plus c equals x squared. So this is when you FOIL, that's what you get. Don't forget the middle term, that minus 2cx, that's a killer. So now what we do is we collect all of the squares together. Well, we only have a plus c, which is x squared, plus, then in parentheses we collect all of from the single x's, which is b minus 2c. And then we just put minus a plus b plus c equal to x squared plus 0x plus 0. I want to use those placeholders so I can use my colors. Coefficient of x squared has to be coefficient of x squared. So a plus c is 1. Blue. Coefficient of x has to be coefficient of x. So blue equation is b minus 2c is 0. And in purple, let's say, the constant here has to be equal to the constant at the end. So negative a plus b plus c is equal to 0. you have A, B, C. Of course, you're going to have three equations with three unknowns, A, B, and C, and you have to find them all. So now you can write this system in an easier way, so you can line it up so you can see what you need to do. So clearly, the middle equation has no A, and the first and third equation have A and and negative A. So if we add the first and third equation, that will kill A, and the middle equation doesn't have A, so we're good to go there. Add these two equations into 2C equals 1. Whoa, C is a half right off the bat. Nice. Go into equation B minus 2C equals 0. Plug that in. So B minus 2 times 1/2 is...
Yeah, isn't it 0?
No, it's B minus.
Wait, so why are we using
Oh, wait. What?
Yeah, why you're using the number to the second equation, right?
Well, yeah, let me just... so B minus 1 is 0, so B is 1. And A must be 0. Okay, so let's
You took away the B from the two.
so let's see. I'm going back to explain this. So focus.
I'm focused.
Once I come up with this equation here, I look at the coefficient of x squared and the coefficient of x squared. Coefficient of x squared on the left-hand side is a plus c. Coefficient on the right-hand side is 1, because it's 1 times x squared. So I get the first equation. Shh, wait, we'll get there. Then I compare the coefficients of the second and the same way coefficients of the third, and I get all three equations that way. Now, what I do with those three equations is I write them so I line up A's under A's, B's under B's, and C's under C's, so I can do the analysis and see what to remove and how to quickly solve the system. I see that A and negative A are present with the middle equation not having A at all. I am going to save middle equation as is because it doesn't have A, and I'm going to add first and the second equation. Sorry, first and the third equation. Oh, there's a B there. Okay. So we just erase this. It's all good. I went a little bit too fast. So we have these guys, when I add the first and the third equation, A and A cancel. 0 plus B is B plus 2C equals to 1. And the middle equation, which I did not touch, goes underneath. And now I have system of two equations to unknown. I add them again. And I get 2B is equal to 1, from where B is a half. So now that I know that B is a half, I can use any of the two equations to come up with C. So 1/2 plus 2C is equal to 1. 2C is equal to 1/2. And C is a quarter. And then A must be 3/4 because A plus C is 1. So A plus C is 1. A plus 1/4 is 1, from where A is 3/4. Now, what is the answer? The answer is not these fractions. The answer is when you put those fractions into this. That's what the answer is. Because the goal of this is not to come up with some A, B, and C and walk away. The goal is to find these A, B, C values, plug them in, so that we can do something with this. which is partial fraction decomposition for integrals and Laplace transforms and whatever else later comes up. So a over x minus 1, a over x minus 1, 3/4 over x minus 1, plus b, which is 1/2, over x minus 1 squared, plus c, which was 3/4, no, c is 1/4, over x plus 1. This is the answer. That's the answer. You'll have, I think, like 4 problems to enjoy on the lab, but you have many more on the homework and textbook. 3 problems only? So you can enjoy this, and then obviously, Raphael can do this like this, so just talk to him, stop by office hours. Bye, stream.